Hello friends, welcome to Mu Lessons. So today we will discuss about vector calculus. This video has been divided into 4 parts according to the increasing order of the levels, and we will discuss many things about this vector calculus in further videos. So first of all, we'll start with some basic things, that is the elementary vector analysis. Now what is a vector? Vector is a quantity which has a magnitude and a direction. Now in physics you have learned all those things, that is what is scalar and vector. So just for a review purpose, that scalar is a quantity that has only the magnitude but not direction. There are some examples of scalar at quantities like the mass, volume and distance. Vectors are the quantities which have magnitude and also have a specified direction. Means they are a directed quantity having both magnitude and a direction. So some examples of vectors are acceleration, velocity, force. Now how do we represent a vector as an arrow from the origin O to A? Suppose a vector moves from point O to A, then it has got some magnitude, that is the magnitude is the length of this arrow, and the direction is given at some particular angle with the reference point whichever you take. So this vector is given as OA vector, or you can write it as in this form. So the length of the arrow gives the magnitude of the vector, and that is written as the magnitude of the vector is given as the modulus of the vector, OA vector, or modulus of A. Now talking about the basic vector system, we have already presented a review on this vector calculus covering all these simple parts, the cross product parts, dot product parts and those important parts. So discussing about this basic vector structure, it consists of 3 axes in 3-dimensional, better you can say I, j, k. These are the unit vectors. This gives the direction, basically the directions of this plane, that is I cap, or the unit vector I cap, j cap and k cap gives the direction perpendicular to the planes. Now these unit vectors have some properties like they are perpendicular to each other in the positive directions of the axes, and they have magnitude length at 1. So these are some idea about the basic vector system which we will include in our further studies of vector calculus. Now how we get the direction of any resultant vector? So that is defined by a basic vector system and forms a right hand set, that is the right hand thumb rule. Now in the previous video about the basics of vector calculus, we have seen how we get the direction of the resultant vector when we find out the cross product. The cross product of A and B gives AB sin theta, and the direction is given by the right hand thumb rule. Now what you need to do is just take off your right hand, curl your fingers on the angle, on the increasing degree of the angle. That means if the angle starts from vector A and ends at vector B, then just curl it in this way. Then at that point the direction of the hands or the direction of this thumb will give the direction of the resultant vector. Now by changing the direction of the angle, you will get some different directions. So as we are considering it as a vector, with the change in direction, the whole thing changes. So this is about the right hand thumb rule which gives the direction. Now the magnitude of the vector. Let P lies in considering the 3 axes, the reference points x, y and z. Now the vector OP, we can write it as OP, or in this manner P tilde is defined by OP is equals to x I cap plus y I cap, y j cap plus k cap. Now the magnitude is given as modulus of this vector, which is given as square root of x square plus y square plus z square. Now there are some important points regarding the calculation of vectors, like we have the vector equations. 2 vectors are equal if and only if the corresponding components are equal. That means if we are considering 2 vectors, let us say A and B, A can be represented or A can be written further into its rectangular components as A1 I cap plus A2 j cap plus A3 k cap Similarly, B can be written as form of rectangular components like B1 I cap, B2 j cap and B3 k cap. Then if you want A and B to be equal, then all its coefficients of I, j and k should be equal. That means I1 should be equals to A1 should be equals to B1, A2 should be equals to B2 and A3 should be equals to B3. So in this format we will say if this condition exists or this condition prevails, then we can say that these two vectors are equal because its components, all of its components, corresponding components are equal. Now coming to the addition and subtraction of vectors, these are simple addition and subtraction as we do in the algebraic types, so no need of discussion about them. These are simply addition and subtraction, go hand in hand. Multiplication can be with a scalar and can be with a vector. So first of all, we'll start with the multiplication of a vector by a scalar. If alpha is a scalar, then AB will be AB1 into I plus AB2 into j plus AB3 into k cap. So what happens in this case about the multiplication of vector by scalar, the whole scalar part is individually multiplied with the components of that vector, and hence we get the multiplied product. Suppose given the best part of analyzing these types of video is I have tried to give more and more example, some exercise questions for you, so you will go hand in hand with doing some examples and some homeworks for you, so that will be better. So I have included a lot of examples and questions. So I would suggest you to just get a piece of paper with a pen and just go through it. Now it is given that P is equals to 5 I cap plus j cap minus 3 k cap, and Q is given as 4 I cap minus 3 j cap plus 2 k cap. Now we need to find P plus k, P minus k, magnitude of P, and 2Q minus 10P. Fine. So what does this tell? These two first bit are about the addition and subtraction of the vectors. Second part is calculating the modulus of the vector. Third part is about the scalar multiplication with the vector and then subtracting them. So you can go through them. A5 plus P plus Q, just you can add them. We will get 9 I cap minus 2 j cap minus k cap. For P minus Q, we will get I cap, then 4 j cap, then minus 5 k cap. Now calculating the magnitude of P, square root of whole square root of 5 square plus 1 square plus minus 3 whole square, that means 25 plus 1 26, and again 3 square 9 10 35, square root of 35. Now again 2q minus 10p, you have to individually multiply 2 to whole of this components, 10 to all of these components, and subtract them. So these are quite simple examples at a basic level, so you can try them out. Now coming to the vector products, the vector products can be of two types: scalar product, that is otherwise known as the dot product, or the vector product, or called the cross product. Now suppose we are having given a two vectors A and B written in the components form as A1 I cap plus A2 j cap plus A3 k cap, and B1 I cap, B2 j cap and B3 k cap. Now we can find the scalar product as A dot B. A dot B is given as modulus of A into modulus of B into cos theta. Theta is the angle between A and B. Now suppose it is represented in component form, then you can write it as A1 B1 plus A2 B2 plus A3 B3. Similarly for the vector product, we have A cross B is equals to AB sin theta in case of cross product, that we can find by this matrix form. Just give the directions I, j and k unit vectors and write the components A1 A2 A3 B1 B2 B3, then find the determinant, whole determinant of this part. So the result you get is the result of the cross product. Now remember, the direction of this cross product is given by the right hand thumb rule. Now talking about the application of multiplication of vectors, Given two vectors A and B, they have projections A onto B and is defined as A dot B by B vector. Now we need to find the shadow, or the projection means the shadow of a particular vector on another vector. So you can see from this part, it is given as A dot B by modulus of B. Now the length L will be given in the form of the modulus of A dot B by modulus of B. Similarly, the area of triangles can be calculated as half the cross product of A cross B. So A cross B actually gives the area of a whole parallelogram formed by these two vectors. So for calculating the triangle, we get half A cross B. The area of parallelogram using the two vectors is given as modulus of A cross B. The volume of tetrahedron and parallel biped can also be calculated, like the volume of tetrahedron having three vectors is given as 1 by 6 into A dot B cross C. For finding A dot B cross C, just go with the determinant form of the matrix given A1, A2, A3, B1, B2, B3 and C1, C2, C3. 1 by 6 of A dot B cross C gives the volume of the tetrahedron. The volume of this parallel biped is given by the triple product, that is A dot B cross C. So here we have an example. Given A is equals to, in this rectangular form, B, you need to determine A dot B and A cross B and the angle between A and B. So you can go through the previous slides and you can calculate. Now we'll talk about the vector differential calculus. Let A be a vector depending on the parameter u. So we can write it as, in the rectangular form, ax u I cap, ay of u j cap and az of u k cap. We have to calculate the derivative of a of u, and that is obtained by differentiating each component separately. That is, dA by du will be dAx by du I cap plus dAy by du j cap plus dAz by du k cap. Similarly, for finding the nth order derivative of that vector au is given as d nth time derivative of dA by du will be dn ax by du whole n I cap dn ay by du n j cap plus dn az by du n k cap. Now if you want to calculate the magnitude of this particular term, or the magnitude of this nth order derivative of a vector, then you can just square root the components. You can square them and then find the square root of the components as we have doing previously. So here is an example. Suppose a vector is given A is 3u square I cap minus 2uj plus 5k. You need to calculate what will be dA by du. So first of all, you need to find the derivative of the whole vector with respect to du. So we will get in this form, somewhat in this form, 6u I cap minus 2j cap plus 0, that is dA by du. And similarly you can find the second derivative of A. So you need to go through these examples. These are very simple examples, just covering the basic form. I am discussing about the slides and then again we are explaining the examples. Now, another example, that is the position of a point or a moving point at time t is given by x equals to 4t plus 3, y equals to t square plus 3t and z is given as tq plus 5t square. So you need to obtain the velocity and the acceleration of the particle. Now suppose if you want to write, then you can write this whole form in a single form, that is, this belongs to I cap, this belongs to j cap and this belongs to k cap. And then again you can find the derivative to get the velocity. Suppose this is the distance or the position vector, then that will become a position vector. Then you need to find the single derivative to get the velocity, then again derivate this velocity to get the acceleration. So the magnitude of both velocity and acceleration at time equals to 1. After finding the derivative, you can put t equals to 1 and find the velocity at time equals to 1 and acceleration as time equals to 1. So it is solved in this form. The solution is given. Suppose the parameter is t and the position vector is rt, that is 4t plus 3 I cap plus t square plus 3t j cap plus t cube plus 5t square k cap. Now in this case the velocity will be given. So I think you are quite acquainted with the physics. So velocity will be given as the derivative of rate of change of distance dr by dt, and if you find dr by dt will get 4 I cap plus 2t plus 3 j cap plus 3t square plus 10t k cap. Now again the acceleration is given as double derivative of d square r by dt square. You find 2j plus 6t plus 10 k cap. Now at time t equals to 1 we need to calculate the velocity and the acceleration. So suppose if you want to calculate the velocity, just put t equals to 1 in the previous form, in this form, and t equals to 1 this form. That will be 6 into 1, just that will be the change. So we'll get the velocity and acceleration in the next part. Now if you want to calculate the magnitude at t equals to 1, the magnitude of the velocity at t equals to 1, so we'll first find the derivative, then we have put t equals to 1. Then if you want to calculate the magnitude, we'll be getting 4 square plus 5 square plus 13 square, that is root over of 210. So this is the magnitude of the velocity which we have got from this vector. Vector analysis is very interesting part. If you are feeling bored, then you just work it out. Try to feel them in the real world where they are used, so you will be enjoying it a lot. Just one more question, can you give an example of this cross product in a daily life? Just think a bit. While opening the doors, while using a hand pump, we all are using this cross product. So whenever you think of such examples, this topic becomes more interesting and you will feel it better. So next, coming to the acceleration part, similarly we will put t equals to 1, then we will find the magnitude of the acceleration. So the differentiation of two vectors can be given if both au and bu are the vectors, then d by du of c of a will be, c is a constant, so we take out this constant outside, c dA by du. d by du a plus b will be the separated derivative of both of the vectors, dA by du plus dB by du. Now we have to find the derivative of a dot b, so we first will take a as constant, derivate dV by du, then again take b as constant and derivate dA by du. For the cross product it goes similarly. So talking about the partial derivatives of a vector, suppose if a vector a depends on more than one vector parameter, then it is given in this form, that is a is a vector which depends on some parameters given as u1, u2 and up to un. So its rectangular components will also be depending upon those parameters, like ax will depend on a1, e2 and un. I cap in a particular direction, I cap gives the direction of this particular vector. Ay is also dependent on the some parameters like u1, u2 and un, and the direction is given as j cap. Az is given by u1, u2, un, and the direction is given as k cap. Now we find the partial derivative of a with respect to u1. Partial derivative, you can find it out. dA by du1 will be dx by du1 I cap plus dy by du1 j cap plus dz by du1 k cap. You can also tell it as dou a by dou y1. Now for double derivative, you can find these are the partial derivative of second order, dou s square by dou x by dou y1 by dou y2 and so on. So here is an example. If f is given as 3uv square I cap plus 2u square minus v j cap plus u cube plus v cube v square k cap, then you need to find dou f by dou y. So by finding dou f by dou y, we get 3v square. This is a partial derivative. You take one of these variables as constant. So I think you are quite aware of this, calculating these partial derivatives. So first of all, you calculate dou f by dou y, dou f by dou v. Similarly, dou square v f by dou u square, dou square f by dou v square. Then dou square f by dou u dou v, dou square f by dou v dou u. All of these values are to be calculated, and we get the whole formula. Now similarly, another example is given. I need you to work out on this. So can you just tell me what will the value of this last part? Will they be same or different? They will be same. Okay. So I need you to work out with this such types of simple problems. Now coming to the vector integral calculus, the concept of vector integral calculus is same as that of the integral and real valued function, except that the result of the vector integral is a vector. Now if you find AU will be AX of UI cap plus AY of UJ cap plus AZ of UK cap. Then for vector integral calculus, that has a limit from A to B, A of U du is equals to limit from A to B AX. Just take the limits of all the components. A limit rising from A to B, AX of U du I cap, A to B, AY of U du J cap, and so on. Just for these things, only the examples are enough. This gives a clear view about how to solve them. If f is given as 3t square plus 4t I cap plus 2t plus minus 5j plus 4t square 40 cube k, then we need to calculate f dt rising from 1 to 3. Just individually integrate them with putting the limits of 1 to 3, and you'll get the result. So this was all about the vector calculus at level 1. These were quite simple, and in the next video we'll go with some more applications and more difficult examples including this vector calculus. Thank you.